Hello and welcome to We Dared Chemistry. Today, we're diving into the fascinating topic of the brand new series on Spectral Series Lecture 2: How Spectral Series Are Formed and Lyman Series. Let's start. Every atom contains a set of energy levels/states that may be represented and explained using Bohr's atomic model. He assigns quantum numbers to energy levels, n equals 1, 2, 3, 4, 5, 6. When electrons go from higher energy levels, Nh, to lower energy ones, Nl, they produce a photon with energy, Nh, Nl. Because the energy related to each state is set, the difference between the energy states is likewise fixed. Hence, the transition between identical energy levels produces the same energy photon. The spectral series is broken into the corresponding series based on the electron transition to a lower energy state. The Greek alphabets are used within the series to segregate the spectral lines of corresponding energy. The spectral series of hydrogen are Lyman series, Nl equals 1. Theodore Lyman founded the series between 1906 and 1914. As a result, it is named for him. According to Bohr's concept, the Lyman series appears when electrons shift from higher energy levels, Nh equals 2, 3, 4, 5, 6, to Nl equals 1 energy state. The wavelengths of the Lyman series are all in the ultraviolet range. Refer to the table below for various wavelengths associated with spectral lines. Energy level, N. Wavelength, lambda in Nm in vacuum. Infinity. 91.175, 93.785, 94.974, 97.256, 102.57, 121.57. If you found this video helpful, please like, share, and subscribe to We Dared Chemistry for more educational content. See you in the next video.